So today, fairly rapidly, we're going to go through the stuff you need to know for the test that you're going to be taking tomorrow on geometry review. Okay? Here's the stuff on angles. Basically, the line that cuts through, it's called a transversal. And the transversal makes a big difference when it comes to things like these ones at the bottom. Because when they say alternate or the same side as, they're talking about their transversal. All right, so interior ones are the ones on the inside, like these guys. The exterior angles are the ones that are on the outside, like A, B, G, and H. Let's see, corresponding are angles that go together. Like a lot of people think A is corresponding to D, but it's not. What's A correspond to? E. Yes, these are corresponding angles. And then, of course, these are corresponding angles with each other. But E and G, the ones that are across from each other like that, those are called what kind of angles? Vertical angles. And those are equal to each other. The ones that are corresponding, like A and E, those were equal to each other also, but those are corresponding. All right, then there's supplementary versus complementary. I try to remember it with supplements. Turn my life around 180 degrees. Supplementary, 180 degrees. And complements make you sit up straighter in your chair, so when you're sitting in your chair, and here's you, stick person. I don't know how you draw a stick person sitting, but anyway, you make a 90-degree angle. Never tried a stick person sitting before. All right, then I think that pretty much covers it. Like alternate interiors are just interiors that are on alternate sides of the line. Like those are alternate interiors, and they are equal to each other. Do you need any more review than that on this part? All right, let's move on. Next. If I asked you to solve for x, you'd be able to say that those two add up to what? 180. So you'd say this plus this equals 180, and you could solve for x. All right. If they have some like that have x's and y's in them, you can write down multiple equations. And if you have a system of two equations, like with an x and a y, then you can solve it using systems of equations. Say you had like 2x plus 5 equals, plus y equals 8, and you had x minus y equals 7. Remember how to solve those systems of equations? The easy way here would be to let those y's cancel each other out, and basically you'd add it down like this. And this would be 3x, and you add those two together, and those would cancel, equals 8 plus 7 is 15. So x must equal 5, and then once you know x is 5, you can plug that in here. 5 minus y would have to be negative 2 to make that work. See what I mean? Just a quick reminder, you can solve systems of equations with either you can do substitution, which would mean like you could have solved this thing for y or for x. Like if I had solved that for x right there, I could have then plugged it back in for y. So just remember, there might be multiple equations that have multiple variables, and you need to be able to solve systems of equations. That's basic algebra, not just higher algebra. Okay, on to the next thing. This is an area of a triangle. I do a base times height, and that's the answer, right? No, then what do you do? Divide by 2. How do you find the area of a circle? Pi r squared. So my common mistake here is people go, oh, x plus 1 squared is x squared plus 1 squared, so it's x squared plus 1. No, it's not. X squared plus 1 times x. Sorry, x plus 1 and x plus 1, when you multiply them, they don't make x squared plus 1. They make first, outside, inside, last. First, x squared, outside, 1x, inside 1x, last 1. So x squared plus 2x plus 1. Then it's times pi. All right. And this one's probably the hardest one. You use average the bases and then times by the height. So average these two and then times by this one. All right. Any more questions on that? Kind of flying through this, but I think you get these pretty well. So, all right, on to the next kind. Are these congruent? Well, there's certain rules that tell you whether or not the things are congruent, and there's like side angle side, side, that kind of stuff. The way I like to think of it is with S's and A's, there's only any combination of 3 letters will be a way to prove it, except the one that's AAA, because 3 angles equally could mean like a really small triangle and a really big triangle, and that means those are not equal and not congruent. All right, so angle doesn't work, and the other one is the bad word, like SSA. Everybody knows that's a bad word, right? If you say it backwards. Okay, so anytime you hit a bad word with you saying it forwards or backwards, then that means that it doesn't work. So all the other ones do work. So side, angle, side, 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 side. And if I say these backwards, they're identical to each other, right? And then angle, angle, side. How about that? Is that okay? Yeah, because if I say it backwards, it still doesn't say a bad word. All right, so that's their way of, a way of remembering these. So let's look at this one we actually have in front of us here. Is it side, angle, side, angle, side, angle? Which one is it? Angle, side, angle, and that's one of the ones that's okay. So it's a yes, angle, side, angle. On to the next one. What do you think? Side, angle, side, side, angle, side. Sorry. Side, angle, angle. Side, angle, angle. And is that an okay thing if I say it backwards? Yep, so it works. So it's a yes. All right. I think we've done enough of those. Yeah. How about that one? This one tricks people sometimes. Side, angle, angle. Just write it out. Now you say it backwards. Does it say anything bad? Appears to me like it works, so it's yes. All right. That red question mark. You could figure it out using what? Pythagorean theorem. Take a second, do it. Pause while you do. And then you subtract 16 from both sides, and you end up with b squared equals 20. And then this is the part where technically when you take the square root of both sides, you're supposed to end up with the absolute value of b is square root of 20. So then b is equal to plus or minus the square root of 20, but the negative is extraneous. I'm probably not going to, I know I'm not going to make you write all of that because it is true, but it's not necessary since it's a shape. We know that those sides can't be negative. So square root of 20 seems like it's good enough, but then you got to keep going. Square root of 5, square root of 4, and then you get 2 root 5. Get that? Okay, on to the next thing. Sine is cosine is adjacent over hypotenuse. Tangent is opposite of adjacent. Okay, and this one, I'm trying to show you that if I move this theta around, then I got to be able to move other things around. Does the hypotenuse move? No, that's the one that stays in the same spot, but these guys switch. Now all of a sudden, adjacent to this is this, and this side's opposite from this. Opposite means across from. All right. Next is 30, 60, 90. I want you to write your helper triangle out. Use X's in this place of the sides so that you can show it in terms of X. Do that for both of these triangles. I'll pause while you do that. Okay, that's good for the 30, 60, 90. And how about the 45, 45? Perfect. Okay, those triangles are handy when you're solving problems like this. Because if you recognize that it's a 45, 45, then that means that the thing across from them must be the same as each other. So this 6 must mean this is 6. And then, what about this one? 6 root 2. It's really fast if you use those helper triangles. Okay, this one. Well, I know that this side here should be half as big as that side there, but that's not helping me very much. If I use my helper triangle, I can go, this is x, this is 2x, and this is x square roots of what? 3. And so then I can just set this equal to this, and that'll be nice and simple. So I say 7 equals x root 3, so I divide both sides by root 3. 7 over square root of 3 is equal to x. Can you leave square root of 3 in the denominator, though? No, you can't. So you have to go 7 over square root of 3 times root 3 over root 3. That's how you cancel those things off. You get 7 roots of 3 over Square root of 9, which is 3. All right.